inferior back here.
That's the medial over that?
This is superior on the left side, but on the right side, the medial actually is more anterior.
Okay.
So we have superior, medial, inferior.
Thank you.
Yes. See, usually when you approach the lungs, you approach them from the back. Like if you're using a stethoscope, you listen to the breath sounds from the back more than you do from the
Except
front.
down.
Yeah, or you
It's
might
upside
listen down here as well.
On
So-
yours? Figure it out.
On yours?
Inferior
Oh.
lobes is really
figure it out.
heard much better in the back, lower area, so.
Thank you.
Okay, where else do we, upper respiratory tract, you can see in this particular model here, we can see the upper respiratory tract, we have our nasal cavity, that narrates, and we have the turbinates, nasal cavity goes into the nasal pharynx, the oral cavity goes to the oropharynx, and then the larynx also has a laryngopharynx. So our pharynx has three sections: nasopharynx, oropharynx, laryngopharynx, and then we go into the larynx down to towards the trachea. Behind the larynx is going to be the esophagus. So this is actually the esophagus right here. Okay, we can see our epiglottis here. And if we look at the oral cavity right here, the palate is the roof of the mouth, and if we follow it all the way to the back of the oral cavity, we see some lymphoid tissue. This is
The yellow?
Yeah, the yellow is the palatine tonsils, and the tip of it that extends down is the uvula.
Which one was the esophagus? Just the bottom tip.
Yeah, just this
Okay.
piece right here. It'll
It's not-
actually go down to the
After
stomach.
the larynx?
This is the larynx right here.
Okay, so that would be esophagus, that would be larynx.
Yeah, right here is esophagus. Just
Okay.
above it, laryngopharynx.
Laryngopharynx.
And then this is oropharynx,
Thank you.
and this is nasopharynx.
Is that off?
That's all we need to know. The name.
That's right there.
The three, uvula.
yellow?
This piece right here is uvula, and the palatine tonsils are right there. Now we also have tonsils at the base of the tongue. If we follow the tongue to the base, we have this tissue right here. These are the lingual or sublingual tonsils. We also have pharyngeal tonsils, sometimes known as adenoids. It has an F on it. This is the tissue right here. This was probably not the best model to show the actual lymphoid tissue. I think there might be actually a better model for it. Let me see if I can grab the blackboard.
No.
Yeah, this is a little bit better. You can actually see the three sets of tonsils here. Here we can see our, okay, get the oral cavity here. Here is the palate. It goes to the pharyngeal tonsils. I'm sorry, the palatine tonsils and to the uvula. Then we see our oropharynx and our nasopharynx, and we can see here pharyngeal tonsils right there, and here at the tongue, base of the tongue, lingual tonsils. So we have tonsils, tonsils, tonsils. Okay, lymphoid tissue. But all the other structures, this is probably a much
The pharyngeal?
pharyngeal, palatine, and lingual.
Thank
And
you.
the uvula is there?
This right here is the uvula. You have to find the oral cavity, then the palate, the roof of the mouth, and follow it all the way to the back. Palatine tonsils, uvula. Okay, and we can see here in the larynx, we can see the ridge that represents the vocal cords, this white line. Okay, you can see the epiglottis. All right, this would be the esophagus, laryngopharynx, oropharynx, nasopharynx. Good. The only other thing we see here, we can see our frontal sinus, and we can see our sphenoid sinus. But you can see the frontal sinus very well here. Okay, good? Yes.
I still don't get the pharynx again. Show me nasal and oral.
Okay. All right, what we do is we find, here's the nasal cavity here, and behind the nasal cavity, this area right here, this is the nasopharynx. This depression right there is actually the opening of the eustachian tube. This is the nasopharynx. And then we look in the oral cavity. Here's our tongue. The oral cavity. At the back of the oral cavity, we have the oropharynx.
Okay.
And then here's the glottis, the larynx. And the back of that, just this section right here, is the laryngopharynx. Anything below that, esophagus. Okay? So for air, we want the air to come in and then go down this way. But we want food to come in and go down that way.
Okay, this one is the
Okay.
layers.
Yeah, the three types of lymphoid tissue: palatine tonsils and uvula,
Okay.
lingual tonsils, and then these
Hell no. I don't even understand this shit. I mean, come on. I'm unemployed. More freaking $150 for this shit. Hello.
Like they're entitled to it.
All right. The only other thing we didn't do, yes, the alveolar sac right here. This alveolar sac, again, this is going to be accompanied with a slide of the alveolus showing the respiratory membrane.
Guys are like the paparazzi.
Yeah, I know, right?
Can y'all give everybody
each
a
of-
chance to see though, please?
Each of these structures represents an alveoli. We actually have a bronchiole. It's covered in lymphatics and blood vessels. This is the bronchiole or airway. It's really a respiratory or terminal bronchiole that leads down to the alveolar sac. And of course, each of these individual alveoli contains a wall of simple squamous epithelium and forms with the blood vessels the respiratory membrane. We'll see the respiratory membrane under the microscope. We're supposed to use this structure here. You can see the squamous cells as a representation of the pleura or pleural membrane that surrounds the lungs. You know, the visceral and parietal pleura. I don't particularly like it that much. I don't think it's wet.
So what are we knowing for that model?
Alveoli of the lungs. This is an alveolus. The whole thing is an alveolar sac. We have our respiratory or terminal bronchiole.
Respiratory?
Or terminal bronchiole. And then we have the blood vessels. We have pulmonary arteries and pulmonary veins. And that's pretty much it. And on the slide, we will show the alveolar wall, which is with our respiratory membrane. Okay, for our urinary system, I brought up this model to show the basic structures of the urinary system. You can see the symphysis pubis here, and what they call the trigone urinary bladder. We have our right and left kidneys, the ureters going down to the urinary bladder. There we go.
What is this called?
This is the symphysis pubis. These are the pubic bones right here. And that's the symphysis pubis. We can see our descending aorta. We can see our ascending inferior vena cava. We can see the renal veins and arteries. We can see the suprarenal glands or adrenal glands. We can even see inside the kidney. You can see your renal pyramids. We can see sort of the calyx, and we don't really even see the pelvis very well, but we can see the ureters. So to see those structures, we need to look at a kidney. We can use this kidney on the stand, or we can use the kidney on the flatboard model. We have our renal cortex right on the outer part of the kidney. The medulla is everything in the inside. So the cortex right here, if we have a slide, this is what will contain the glomerulus and the renal cortex, and the renal tubules will be found in the medulla. The medulla will consist of these triangular shapes called renal pyramids. We have in between each renal pyramid renal columns. The renal pyramid tip is called the renal papilla. It empties into a renal calyx, C-A-L-Y-C-E or X, I can't remember. We got minor and major renal calyces that lead to the renal pelvis right here.
And is
then
that a
the
true
ureter.
representation of how many pyramids are in each?
Yes. It is actually. Yeah, but remember it's three-dimensional, so we're only just seeing one slice. These pyramids will extend through and may have a double layer, just like the glomeruli are in multiple layers.
I'm sorry, can you do it one more time again? Because I didn't get
Yeah, okay, so we have, again, the kidney, we have the renal cortex here. Everything in the center is renal medulla. We have inside the renal medulla, we have renal pyramids, these triangular shaped structures. This as well, they consist of the renal tubules, and the glomeruli are found in the cortex. So we have our renal pyramids. In between the renal pyramids are the renal columns. At the tip of the renal pyramid, right here and here, is called the renal papilla. They empty into the calyces, which empties into the renal pelvis, this area here, which empties into the ureter. Okay, we actually have our renal artery and renal vein, and I think that's that's pretty
How do
much
you
it.
spell calyces?
Calyces is with Calyces is calyces, but the single one is a calyx with an X. YX. Not usually, but something like this would work. Okay, now our other urinary model is this one right here. This particular urinary model, here. Again, we have our large kidney. On this kidney, you can actually see in the cortex, there's our renal cortex, we can actually see these tiny little white dots. Those are glomerulus. We can see those under the microscope. In the renal pyramids, in the medulla, we have renal tubules. So the pyramids are actually made up of renal tubules. The filtration of the blood in the glomerulus, the urine or the pro-urine passes into the renal tubules. So we got our loops of Henle's and so forth, and then our collecting ducts make up our renal pyramids. And the urine goes into the calyces and then into the pelvis and ureter. If we look at a section of the cortex and medulla, that's what we get right here. And what we can see is the basic unit of the kidney, the nephron. And we can see the glomerulus as this structure right over here. It has a kind of bluish purple glomerular capsule. Inside is the glomerular capillary mass. And then we can see a blood vessel entering and a blood vessel exiting the glomerulus. The blood vessel that enters is going to be our afferent arteriole. The blood vessel that exits is the efferent arteriole. The blood vessel that exits will actually end up becoming all of this mass of blood vessels that surrounds the tubules. And these blood vessels are called the peritubular capillaries. So that efferent arteriole will become the peritubular capillaries. Coming out of the back of the glomerulus, we have this light green convoluted structure. It is called the convoluted tubule, the proximal convoluted tubule. It actually goes down into the medulla as a loop and then loops back up again. That loop is called the loop of Henle. We have a descending limb, light green, and an ascending limb, dark green. That dark green limb will then again become a convoluted tubule, and it will be the distal convoluted tubule. That distal convoluted tubule will then empty into this white tubule right here, which is called the collecting duct, and that extends down through our renal papilla, down to the renal papilla and empties into the calyx. Okay, now a closer look of that glomerulus is seen with this model right here.
Into the calyx or the pelvis?
It actually goes first to the calyx and then to the pelvis. Yeah. So here we have our glomerulus right here. We could see the simple squamous epithelium that makes up the glomerular capsule. We could see the tangle of glomerular capillaries inside. This is the blood vessel that enters the glomerulus. This is our afferent arteriole, and then the one that exits is our efferent arteriole. And we have this mass of cells that sits on the afferent arteriole. That mass of cells is called the juxtaglomerular apparatus. This mass of cells is what is going to monitor the blood pressure that in the vessel that enters the kidney. It is responsible for producing hormones that can actually affect your blood pressure. We have our renin, angiotensin. Okay, exiting the back of the glomerulus is our proximal convoluted tubule right there. Okay, what else do we have?
We just need to identify this, right?
Yeah.
We don't have to.
No.